Okay, this is Miss Webb, and this is the second part, and I'm hoping my cat will not scream the entire time because she's driving me nuts. She wants to go outside. Okay, now I would like you to think about this a little bit. The one before was x was to the first power. It was linear, and the first degree was constant, second degree was 0. This one, the degree is 2. Can you kind of make a guess as to what the first difference would be, second difference, and the third difference? Just make a guess so that when we go over it, you can think about it and see if you're right. I mean, who knows? Let's say, well, maybe, well, no, I'll let you think about it a little bit. Okay? So what I'm going to do right here is I'm going to fill in the columns. Okay? If x is 0, and I put in a 0 for x right here, then I get a 0 plus 0 plus c. I'm left with c. It's the only thing I'm left with. Now, if I put a 1 in for x, well, 1 squared is 1. So I'm ending up with an a plus b, because I put in a 1 for x, plus c. A plus b plus c. Let's put a 2 in now. If I put a 2 in for x, 2 squared is 4. So I'm going to get a 4a plus 2b plus c. Do you see how I got that? I'm just putting a 2 in for x up here. Now if I put a 3 in for x, I'm going to get a times 3 squared is 9 plus 3b plus c. There it is. And the 4, well, it'll be a 16a plus 4x plus c. Okay. Now let's see, can you tell me what the first difference is going to be? Well, a plus b plus c minus c. And these are all, the difference here is only 1, so I'm dividing by 1. So a plus b plus c, subtract c, I'm left with ab. Okay. Now I have 4a plus 2b plus c, and I'm going to subtract a plus b plus c. What's 4a minus a? Don't you get a 3a? What's 2b minus b? I get a b. What's c minus c? Disappears, no c in there. There it is. Do you see that? 4a minus a is 3a. 2b minus b is 1b. Cool. Now if I do the next one, I'm going to say 9a minus 4a is 5a. Let's see if I got that. 5, yep, I'm getting a 5a. 3b minus 2b is a 1b. And then the c's cancel. C minus c is 0. I bet you can kind of see how this is going. I'm willing to guess on this one. I'm willing to guess that without even looking over here, I'm going to say this is going to be 7a plus b. So if I look over here, 16 minus 9, don't I get a 7a? 7a plus b. Okay. So this is a degree of 2. So I have that difference. Hold on just a minute. Keep going. I had to go put the cat outside. Okay, now what do you think about this second difference? Can you make a guess there? I bet it's going to be a constant. I don't know. Let's look. 3a plus b minus a plus b. Well, 3a minus a gives me a 2a. b minus b, they cancel. I end up with a 2a is the second difference. 5a minus 3a is 2a. The b's cancel. Look, it's 2a every single time. That's a constant. It's a constant number. Remember, what does the a stand for? Well, that was that leading coefficient of this polynomial. And then the third difference is 0. So what are we going to deduce here, our deduction? Well, if you're a polynomial to the second degree, then your second difference is going to be a constant. And it's not just going to be any constant, it's going to be 2a, 2 times the leading coefficient. Third difference is always going to be 0. Pretty interesting. And we can actually do this all the way up with your polynomials, and you will find that this is true for every single polynomial. Okay, let me move these back, and let's see what I put on here on how we're going to deduce it. So if you have a sequence of a polynomial to the second degree, where n plus 1 plus n plus 2, the second difference is a constant. It's always going to be a constant 2a. And the third difference is always going to be 0. Now, when we were looking at something with the first, just the power of 1, remember the 0 went in the second difference, and the first difference was a constant. Okay? So let's try one more. Okay. Oh my goodness, I'm going to do one of the third degree. Can you guess what's going to happen? Well, I'm pretty sure that fourth difference, it's going to be a 0, right? Yeah. What do you think that third difference is going to be? I don't know. Let's go find out. Okay. If I put a 0 in for x, I get 0, 0, 0. I'm left with d. So I'm going to do that first column. Okay, if I put a 1 in for x, I get an a plus b plus c plus d. 2 in for x. Well, 2 cubed is 8. 2 squared is 4. And then I just put the 2 and the d. So that's where I got the 8. I cubed 2. 4 is I took the square root of 2. I mean, not the square root. I squared it. Okay. And then I'm just plugging in that value of x here into this function. So the next one, let's see how well you know your cubes. Okay. So if I put in a 3 there for x, well, 3 cubed happens to be 27. 3 squared is 9. Then I have 3c plus d. How about 4? Okay, 4 cubed is 64. So if I give you this and I give you the function, you should be able to figure out what goes in this column. So my first degree, let's see what happens on the first degree. If I take this and I subtract d from it, I get a plus b plus c. There we go. Now if I take this one, 8a, 4b, 2c, d, and I minus a, b, c, d, I'm going to get a 7a, a 3b, a c, and the d's cancel. There we go. Now if I subtract here, 27 minus 8, what's that going to give me? Like a 19? 9 minus 4 is a 5, 3 minus 2 is a 1, the d's cancel. I get a 19. That one's kind of wild. Okay, now the 64. Okay, 64 minus 27, I don't know, I'm going to have to get my calculator out. And look what I got here. I got 64 minus 27 is 37, 16 minus 9 is 7, 4c minus 3c is a c. Okay, I get these numbers here. Okay, but let's go see what the second difference is. If I go look at the second difference and I say 7a plus 3b plus c and I minus this guy up here, I am going to get a 6a and a 2b. The c's cancel. On this one, I'm going to get, let's see, 19 minus 7, 12a plus 2b. This one, 37 minus 19. I'm going to get an 18a plus 2b. 7 minus 5 is the 2. C minus C, it cancels. 37 minus 19, 18. Now let's see what the third difference is. I'm thinking the third difference is going to be my constant. So what's 12a minus 6a? Well, that gives me a 6. Oops. Mrs. Webb made a mistake in her little guide. This should say A. 6a. Okay. Then if I come down again, this should say 6a. Okay. And then the difference between 6a and 6a is 0. So what am I going to be able to deduce from this? I'm going to say, okay, if I have a polynomial and it's a third degree, my degree is 3, that means my fourth difference will always be 0. My third difference will always be 6a. Pretty cool. I think it's pretty cool. This is the pattern that you see. Okay, so if you have ax plus b, that's a first degree. This is a second degree, ax squared plus bx plus c, third degree, and fourth degree. And this is the pattern. On that first degree, you get a constant and you get 0. For a quadratic, you get 2a as the constant, third difference is 0. On a cube, you're going to get 6a as the constant, and it's going to be the fourth difference. The fourth difference, that's 0. So if you had a polynomial to the fourth degree, well, I know the fifth difference is going to be 0, but can you tell me what would belong right here? Any guesses here? Most people go, oh, a, 2a, 6a, maybe it's going to be a 9a. I don't know. Well, I'm going to show you what it is. Something you haven't seen before, I don't think. It's called factorial. 1 factorial is 1 times 1. That's where you get the 1a. 2 factorial, 2 times 1, I get 2a. 3 factorial, 3 times 2 times 1, that's equal to 6. If I was going to do a fourth degree polynomial, I would take 4 factorial, which is 4 times 3 times 2 times 1, and I would get a 24 here. I would get a 24a here. And my fifth difference would be a 0. And that's the really big pattern that you see. Okay, how does that help me, Miss Webb? I don't really care, so it's kind of cool. Well, I'm going to show you how we can use it. Okay, but I'm going to stop here, and I'm going to stop the video, and I'm going to do it, like I said, in 3 parts. Okay?